Right, so to calculate the greatest coefficient of our binomial product of a plus b all to the power of n, we can use the following formula. Okay, so we can work this out longhand as well, and I'll show you one example where you can. So in case you don't remember that formula, we can go through the process and working it out. Okay, so we need to do a comparison of the of one term, which we'll call t of k plus 1, which is our general term, when we have the formula, and we need to compare it with the previous term. Okay, so we're going to find the value for k that makes the previous term less than the current term, but we also need to find that point where the term is going to be less than the previous term. That's going to be the tipping point for us to determine the greatest coefficient. Okay, so examples. Let's find the greatest coefficient in that expansion. So we're not going to require you to expand it right out to find the greatest coefficient, although you can do that. Okay, so if you forget how to do this, you can expand the whole thing out and then identify which is the greatest, which will take time, okay, but you'll get your answer with that time, but this will be a much more efficient way to do it. Right, so t of k plus 1 over the previous term. Okay, so remember the power is n, this is a, this is b, and we're going to solve for k in that formula in a moment. Right, so it's going to be 20 take away k plus 1 over k times 3 over 2. Okay, so 21 take away k, so that would be 3 lots of that, all over 2k. Just tidying up in that manner. Alright, so for greatest coefficient, okay, we need to find the point and the value for k where our current term is greater than the previous term. Alright, so we've got k plus 1 and the previous term of t of k. We need to find that point, that value for k, that makes that inequality true. Okay, so in other words, t of k plus 1 over t of k must be greater than 1. The ratio of the term, the coefficient to the previous coefficient has to be greater than 1 for the top one to be larger. Okay, so 3 outside of 21 take away k, all over 2k, so that's what we've simplified already, has to be greater than 1. We need to solve to get that value for k. Okay, a couple of things you can do. You can cross multiply, have this as a fraction, or we can expand this out. Okay, which is what I'm going to do. So 21 threes is 63 take away 3k is greater than, and I'm going to bring that up to that side, 2k. Alright, I'm going to bring the negative 3k onto the right hand side of inequality. So 63 is greater than 5k. Divide both sides by 5. We're going to have 12 and 3 over 5. So we're going to 12.6, which is greater than k. Alright, now you need to determine the value for k that makes the greatest coefficient. Any suggestions what I'm going to do here? Alright, k equals 0. Remember we can have a k 0. Alright, does that match that inequality? Is 12.6 greater than 0? Yeah. Alright, what about k is 1? Yep, so what value up to is that going to match for my integers of k? So when k equals 12, that's going to match because 12.6 is greater than k, but when k is equal to 13, that's the first value is going to fail. Alright, so in other words, this previous term is going to be greater than this term. Alright, but when k is 11, this term is going to be greater than the previous term because it matches that inequality here. Okay, so that largest value you can have here that matches that inequality is going to be the value for k that will give you your largest coefficient. So therefore k is 12 gives greatest coefficient. Perhaps make a note of that because, or that you are telling me which value for k. Right, make a note of that, make it clear that this is the value you're going to consider, okay, because I imagine this will be 2, maybe 3 marks, okay, 1 mark to get the inequality, 2nd mark to get the value for k, and then 3rd mark to give me then the coefficient. Right, so our general term, which we've already written, when we do the expansion of that, okay, so our value for k is 12. The 2 plus 3x to the power of 20. Okay, so it equals 20 C12. So we're doing our general term now of A. The 2 to the power of 20 take away 12 which is 8. And we just need the coefficient, we don't need the variable. Alright, so my B is just going to be 3. 3 to the power of k. And that will give me my greatest coefficient for my expansion. Now I am predicting that's going to be a very big number. Can we calculate it and tell me what it is? You leave it on purpose, did you? Okay, when you have something like that, okay, in your calculator, at this point you would leave it as it is there. Okay, so consider the expression. For the greatest value for k, when the number you put in the calculator is large like that, okay, I would actually leave it like that. Alright, and most points in when you get the very large values here, they're just left like that. Alright, so we'll just leave it like that. And hopefully, without any errors in my working, that will provide us the greatest coefficient. Okay, so you need to remember this formula. Okay, so it makes it nice and straightforward in terms of substituting in and solving for k. If we don't remember this formula, we actually need to write out the general term for t of k plus 1, which is that replacing that and that with your k's, and also with your t of k plus 1, t of k, you've got to write the general expansion for that, and then you have to simplify that fraction involving your factorial notation, etc., etc. So it is my highly recommendation that you remember this formula or this concept. Try the second one. Okay, so now we're told we're leaving it factored. Okay, so I probably should have said that at the previous one. So we need to find the greatest coefficient of that expansion, leaving it factored. So the formula, T term of k plus 1 over the previous term is going to be n take away k plus 1 over k times b over a. Okay, that's the formula I need to remember to start. Right, so 15 take away k plus 1 over k times 2, make sure that fraction's written in the correct order, b over a. So now general expansion a plus b to the n. make sure you have your fraction, otherwise it will not be correct. Right, so we simplify that. So it'll be 16 take away k over 5k, and we got times by 2 out the front. Right, so what you are doing is finding the value for k with that inequality that we're about to write. That will provide the greatest coefficient. Okay, so for greatest coefficient, so t term k plus 1 must be greater than term k. Okay, so we're comparing the current term and we need it to be greater than the previous term. Remember, when we do our expansion, there will be a point where it will be the greatest, and then it'll go down and get less and less. Depending on the values A and B, we need to know where that term is. So for the greatest coefficient, we got that. So in other words, t of k plus 1 over t of k has to be greater than 1. So what I've done is written that as a fraction. So I've brought tk underneath to match what we've done over there. So 32 take away 2k is greater than 5k. So we're putting that expression in here. I'm cross multiplying. I'm going to get the value for k that matches that. So 32 is greater than 7k. So we have 4 and 4/7 is greater than k. Right, so if you get to that point, I think you'll probably get your first mark out of 3. If it's only 2 marks, you probably need to tell me what the value for k is, and then your substitution. Right, so k equals 0, does it work? K equals 1, k equals 2, k equals 3, k is 4, k is 5. Alright, so there's our tipping point, because 4 and 4/7 is greater than 4, but 4 and 4/7 is not greater than 5. Alright, so therefore, k equals 4. Gives the greatest coefficient. Alright, so make a note of that. Alright, don't go to the next step without making a statement of what the value is, okay? Because if you don't get the next step correct, you get your part mark for that stage there, assuming you're correct. Right, so term k plus 1, so we're going back to a couple of lessons ago where we wrote the general term expansion. So 5 plus 2x to the power of 15. So it's going to be n, which is 15, c, hang on, k is 4. Yeah, that's right, yep. It's 15c4 of 5 to the power of 15 take away 4, and just the coefficient. We don't need the variable, because just finding the coefficient, right? To the power of 4. Right, leave it factors, that's what it means, alright? Just leave it in that form. Okay, so give me the general representation of the term, and we'll leave it in combinations and factorial notation. Because again, if we do 5 to the power of 4, that's going to, 5 to the power of 11, it's going to be a ridiculous large number. Right. 10.4. So you have the rest of